Hi, this is Jay Arthur, and welcome to Breakthrough Improvement with Excel. In this segment, I'm going to talk about how to reduce variation. Now, what's variation? Well, it can be something as simple as how long it takes to handle a customer service call, or standing in line at a credit union, or a patient waiting for a procedure. I mean, there's variation in how long it takes to get to the procedure and how long procedures and things take. And so we can reduce variation in any of those things. From a manufacturing standpoint, sometimes we make things that are just too big or too small, right? And so we have some variation, and that variability makes things not fit together like they ought to, and so on. And I'm sure you've all had that experience. Even going to a restaurant, you've probably noticed that, sometimes your food's a little too hot or a little too cold or a little too something, right? So there's some variability. We want to be able to reduce that. So this is a four-step process, FISH, or FISH for short. We're going to start by focusing. We're going to use some data in Excel to do that. Then we're going to actually start to improve. We're going to start to ask, well, why? What's the root cause of these things? And then how do we implement some improvements to make that better? Then we have to sustain the improvement, because otherwise we'll just slide back into our old level of performance. And we're going to use some tools in Excel to do that. And then we want to honor our progress. We want to recognize the people involved, because that's how these things continue. So the first step is really in focusing is we need to take and draw a control chart. This is a time series plot that shows how we're doing over time. Is it consistent? Is it predictable? And if you really want to make improvements and sustain them, you have to have control charts, because we're going to use these control charts later on in the sustain phase. So this tells us, can we count on this thing to produce a predictable result? Then we're also going to use a histogram to show the distribution of our data, right? And we're going to figure out how capable is our process. So the control chart is about stability. The histogram is about capability. And here you can see we have a bunch of stuff that's outside of our upper spec limit, which is, beyond what our customer wants. Next, we're going to ask the 5 whys. Why did this happen? And we're going to develop a cause and effect diagram. This is what root cause analysis is all about. And we can draw this with a tool in Excel. Then we have to measure our before and our after, right? We want to verify this. Did we actually reduce the variation? Did we get our histogram to fit within our upper and lower spec limits? In the control chart phase, we're also going to compare and make sure that we reduce the variation, right? We don't want it to get wider, we want it to get narrower. And then we want to monitor that thing ongoing. And so this is the structure of how we're going to track whether we're staying on track. And if we don't have a control chart, I can guarantee you, you simply won't be able to detect when your process shifts and you start going wrong again. We're going to continue to look at our histogram, so we're going to use the control chart and the histogram to sustain and monitor things and correct when we go off course. And then we want to honor the team for making these improvements. And dramatic reductions in cycle time and quality and everything else. You can really make things a lot better very quickly if you really use these tools to focus. We make the QI macros for Excel, which are a real affordable tool to help you draw control charts and histograms and fishbones and so on to make breakthrough improvements. And you can go out and find out more about the QI macros at qimacros.com. And you can also go learn more about breakthrough improvement with Excel at biqixl.com.